Okay, I'm going to start this video slightly part of the way through because I was filming and then Mr. Ladd walked into my classroom. But in this video, we want to be able to recognize and name aldehydes and ketones, describe the oxidation of primary, secondary, and tertiary alcohols, and describe the oxidation of aldehydes. So, some of this stuff we'll be very, very familiar with from AS. So, primary alcohol, oxidize it once, it'll become an aldehyde. You can then oxidize the aldehyde to the carboxylic acid. Obviously, if you start with just an aldehyde and you do oxidation of an aldehyde, you get straight to the carboxylic acid. Okay, so you don't have to start from the primary alcohol. Oxidation of secondary alcohol goes to a ketone. Oxidation of tertiary alcohol, no reaction. And then obviously we covered AS. If we've got a primary alcohol, we want to make the aldehyde, distillation, alcohol to carboxylic acid, got to reflux it. Okay, secondary alcohol to a ketone, doesn't really matter whether you do distillation or reflux, just got to make that reaction happen. Okay, so carbonyl compounds, it's a new thing we're learning about. So bonding in carbonyls. An aldehyde and a ketone are examples of carbonyls. So I'll show you what I mean by that. If we have a C with two bonds there and we draw it flat, if it has a double bond to oxygen, that makes it a carbonyl. The reason why carboxylic acid is not a carbonyl, because this is an OH here or there, and that actually interferes with our carbonyl. And obviously oxygen is quite electronegative, so it's delta minus. Carbon is therefore delta plus. And we have these p orbitals above the bond, and we also have a pair of them below. And they overlap to form a pi orbital. Sorry, I shouldn't have drawn the second bond in there, because the second bond is shown by these orbitals overlapping. So you get an overlap of the electrons here and the electrons there. Okay? And we've seen very similar bonding patterns in benzene with our orbitals, so we end up with a pi orbital below and above the bond. Okay? And so we can just put as a note there, p orbitals overlap to form a pi bond. So this C double bond O is the functional group. And if you have COOH, it's technically not a carbonyl any longer. Okay? So, naming. So naming carbonyl compounds. The C of the C double bond O is always carbon 1. Okay? Sorry, in an aldehyde. Got to be a little bit more specific there. So, for example, we could have these three compounds. Okay, so this, let's move that up a bit. This, as you can tell, is ethanol. This is 3-chloropropanol. And this one here is 3-methyl-butanol. Okay. Ketones, we need to use lowest numbers, and you'll see what I mean by this. spectrum. Okay, so ketones are a little bit like alcohols and alkenes in how we name them. So you do the carbon stem, 1, 2, 3, 4, and then butan because it's an alkene. So it's butan and then 2 one. Now, obviously, those of you who are particularly quick will realise that butan 2-one can only be butan 2-one, so the double bond would be there. So you could get away with saying butanone, but anything longer than that, anything with 5 carbons or more, we're going to have to start being specific. So, for example, here, this is pentan 3-one. And obviously here we have pentan 2-one, so we have to be specific. And then this compound, starting to get a bit tricky, but we've got 1, 2, 3, 4, 5, so it's pent. And then we've got a double bond on carbon 1, so pent 1. And because we've got a double bond, we can't use an like we did here. So it's pent 1N 3-one. So pent 1N 3-one. So quite tricky there, that one. And similar for an aldehyde. If you had, say, an aldehyde on the end here, it would be pent 4N and pent 4N al. Yeah, it's quite tricky. Okay, and we'll look at just one more thing. If you have what is known as an aromatic aldehyde or ketone, and that just means you've got a benzene ring and a carbonyl in the same compound. So, for example, this compound here would be benzaldehyde, and then this compound here would be phenyl ethanone. Okay, and you wouldn't really be asked. You've got benz there and you've got phenyl here, a bit confusing. I wouldn't expect you to be asked to name an aromatic aldehyde or ketone, but it's good to be aware that they do exist and that we might expect them to take part in reactions. So you'd be more likely to say, here's an aromatic aldehyde, it's called this, how does it react? Okay, so it's more about being aware that these compounds exist and just realising that it's just an aldehyde or a ketone. Okay?